Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bumpers. It's a fun show. We dive deeper in the robots and what makes them work. And today I'm here with team number 3039, Wildcat Robotics from Drivetrain, Louisiana. 3039 dates back to the 2009 season, where it's brought home 2 event wins, 3 finalist awards, and an Engineering Inspiration Award. They had an opportunity to compete last season at the Arkansas Regional, where they made the playoffs and took home the Autonomous Award. This year for the at-home challenges, 3039 took 8th place in their division. And today I'm here with Jacob, Mitchell, Savannah, and Bodie. And we're going to be diving more into this modified 2020 robot. Some cool modifications made. Can't wait to learn a bit more about how the power cell works on this robot. All here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Jacob, starting off on this robot here, we're going to be starting off with the intake and going to the hopper. So I'd love to hear more about how it works, and if you don't mind, talk to me about some of the modifications that made from 2020 into the 2021 season.
Alrighty, so the main part of our intake is we use the floating roller, which starts at the competition up and drops down whenever the game starts. So the floating roller here, so the balls come in, intake pops up a little bit, and goes to the hopper, and we had it come up in the middle of the game as well, so the intake folds up, and we did that to prevent balls from popping out of the hopper as we're driving, as well as to be able to have balls from the human player during the game. We have the wheel here. We went with 1 wheel to prevent jamming. We tried 2, but we found that with 2 wheels spinning, even at different speeds, the ball still jammed, so we only used 1 and kicked the other ball out. So we held 3 balls in the hopper itself, and then 2 in the staging system. And some main changes we added since last year is we changed this whole roller and then added these black rubber rings around it, which picked up the balls a little bit better and were a little bit stickier to the ball.
So Jacob, I want to start here, if you don't mind. Let's talk a little bit about the intake here. And something that I noticed that you have on it is a very beefy crossbar as it goes on that. Yeah. So was that something that I'm going to assume was added in case like you get hit by another robot? And did you have that originally on your bot, or was that added later on?
No, we had it from the start. And yes, it's to make it a little bit beefier in case we get hit. It's a little bit more stable. We had this from the beginning. We had other years we found that having that stability bar definitely helps. So when the Lexan gets hit or something, it stays stiff and keeps the same angle pretty much the entire time, no matter how we're hit. And a little bit rougher in the game, so we decided to add that bar. We had it from the start, though.
Yeah, sure. And then on the hopper itself, something to ask, I get the advantage of having the open hopper in regards to, it allows you to utilize the human player load system, but what do you do to mitigate power cells popping out should your robot be hit during a match or anything like that?
We did find that was a problem with aggressive driving. So besides the intake folding up, we have a plan that we have planning to add, which kind of works as like a fold over that's going to go over it. Imagine like a key. It's gonna work as like a blind, and imagine like a key ring, so it kind of pulls out. So as it's gonna be attached to that, and as the intake folds down, the blind's gonna come over it and block the balls in as a cage.
Looks very efficient. Yeah, it looks very efficient to me on that. And I think this is a great transition to go into Mitchell, who's going to be talking about the transfer into the turret and then the turret itself. And then I know Savannah's going to be talking about some of the adjustable hood as well, too. But Mitchell, start us off with the transfer and then the actual turret on your bot.
Okay. So starting from our 3-ball hopper, it comes to a 2-ball staging. And from there, we have 2 sets of beam brakes that allow us to have 2 separate motors powered. One will continue spinning, and the top one will stop. This allows us to have 1 ball stage and then bring another one right up behind it, ready to shoot after. And then right after there, it comes to our turret. And if you come up this way, We're very close, and that second beam brake is right at the top, so we get right at the beginning. Our turret is 360 degrees motion, but we have a electronically limited to about 270 just for safety precautions. As you can see, we go facing this way. It's the limit, and it'll come all the way back around 360.
Can you talk to me a little bit more about the wheels on your bot and also the flywheel being used as well? Not just on the shooter. I'd love to hear about that, the top wheel as well too, and kind of what motors do you have connected into that? Any additional specs on that?
So on our actual main wheel, we have 2 flywheels, 1 on each side. Both weigh about 1 pound, so we're at 2 pounds total. On our top, we only have 2 2-inch wheels, and they spin freely. There is no flywheel up top, so as other teams may notice, there's a little bit drop off in speed, but we notice at the top there isn't as much at the bottom since most of the compression is down at the bottom wheel. And then, for the motors, we have independently powered. So we have 2 Falcons powering the shooter, and then up top on our top wheel, we have one 775 Pro. We use a custom gearbox from the Falcon. As you can see in here, it was all designed in-house and goes from about a 7-to-1.
So the question I have in regards to your shooter, how much time does it typically take, one, for your shooter to get up to speed, and then how much of a delay is there between power cell shooting? And I know we'll see the robot shooting in a little bit, but are you able to pretty much just shoot rapid fire, or is there a little bit of a break in between?
So starting up, shooting up, we have about 1 to 1.5 second of speed up time, and then our delay is pretty much rapid fire. Sometimes with the hopper, we'll have like a half-second gap, but it's rapid fire every time else.
And then do you know anything in regards to how much like compression you're putting on the power cell as it's in your robot going up, in from your hopper into your shooter?
Yeah, so if we look down to our staging area, it has about 1.5 inches of compression. And then for our shooter, we have 2 inches.
So one of the things I know we'll be bringing in Savannah to talk about is the adjustable hood on your robot that got modified from 2020 into 2021. So Savannah, I'd love to hear more about your adjustable hood, how that's benefited you, both for the Infinite Recharge Challenge and then also the at-home challenges as well too. And then we'll be hopping more into your drivetrain. But let's talk a little bit more about the adjustable hood on your bot.
Okay, so for the 2020 season, we had just an arch shooter with no top roller, and it came down with a piston so that we could fit under the color wheel. But this year for the 2021 game, we decided that we really wanted an adjustable hood because that would fit the challenges better. So we 3D modeled custom gears that attach to a Rev Smart Servo to move up this larger gear that we made, and then we cut into like a sector gear. And then we used a Vex 775 Pro and GT2 belts to power 2-inch Andy Mark wheels. And we cut out a Delrin, so a slot, so that the bolts could ride smoothly and easily.
So those Andy Mark wheels, those were added from 2020 as well?
2020, we did not have a top roller at all. We just had this piece.
Sure.
And churros that went across. So we could shoot from like one position very well, but we couldn't shoot with that much oomph to like get from farther spots. That's why we decided that one of the main things we needed to make our shooter better was a top roller.
Yeah, and before we get into the drivetrain, can we see a couple power cells with a nice close-up shot of the shooter of just seeing those power cells exit your robot so we can see how that power cell journey works out? So Savannah, now we've talked about the power cell. Let's go into your drivetrain. I know you got a couple custom pieces that have been done with your gearboxes and a little bit more. So talk to me about what's going on with the drivetrain side of the robot.
So we went with pneumatic wheels this year to get over those bumps in the middle of the field. So we decided to use chain, and we have custom bearing blocks that are designed similar to the Vex bearing blocks, but these we custom made so that we could raise up the wheel another 1/8 of an inch, just so that the top wheels could get over the bump fast and quickly, and also it helps us turn better. We also custom designed our gearboxes, which is 2 Falcons to a 9-to-1 ratio.
All right, well, Savannah, thanks for talking to us about the drivetrain and, of course, the implemented adjustable hood that you had on that. So we're going to be going next into Bodie. Is going to be talking a little bit more about the sensors. I know a couple beam brakes were already mentioned, but I'd love to hear more about some of the insides of the robot and then any of the programming you want to discuss that went into this robot as well, too, Bodie.
Sounds great. So at the beginning of this season, at our big programming meeting, we decided that one of our goals was going to be to have a more state-oriented system for programming. So everything in the code is hooked up to one central enum that dictates the state of the robot. So we have a master state machine that controls everything. So we have 2 beam brakes, one at the bottom of the hopper and one at the top. So what these do, while we're intaking, they stop from rolling up to the shooter. They keep it in place. So we get a video of the while it's intaking. So once these balls go up to the hopper, to the carriage, the turret is operated on a P controller and with a little derivative in there. So because we feel need to have a full PID system, just the P controller on it, it operates pretty smoothly. It can be a little sharp sometimes, but in function, it works pretty well on the field. And the last thing I want to talk about is for our autonomous and our drivetrain, we use odometry, and we found it works pretty well. We thought about using a pose estimator at one point, but odometry works pretty well for our paths and our auto. And everything, with the 4-wheel drive, we calibrate everything for the kinematics, and it works pretty well. It's very smooth for the drivetrain.
3039, thank you so much for taking the time to speak with us about your robot, what goes into it. Definitely, first time I've had a chance to talk to your team, so delighted to do so and learn a bit more about what goes into it. Congratulations on your performance for the at-home challenges. Can't wait to see your robot perform in future years. Never know, might even see this robot compete at a competition later on during the year. So good luck if that takes place, and good luck during future competition seasons. Thanks for taking the time.
Thank you. Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.